graphs?
Graphs are used to visually represent data. Often, it's easier to see the story in the data in a graph rather than in a table. We're going to go over the most common types of graphs.
A bar graph uses bars to represent data. Simple, right? Bar graphs can make it easier to compare quantities. Let's walk through how to convert a table into a bar graph.
This table shows the responses 20 people gave after they stubbed their toes.
The first step in converting a table to a bar graph is to label the axes. We're going to put response on the horizontal axis, the bottom one, and the number of people on the vertical axis, the side one. Make a scale appropriate for the data. Now, we're ready to plot each response.
We have one response for ooh. So let's draw that bar.
Ouch!
3,
Ah!
11, and 5. With a bar graph, it's easier to compare the data with each other. People say
Ah!
after stubbing their toe a bit over twice as much as they say They say more than
Ouch!
and almost none of them say
Ooh!
The bars in bar graphs usually run vertically, like this one, but there's no rules saying they can't run horizontally, like so. It's all the same.
Sometimes you'll have so many values that you can't fit them all on a graph. That's when you want to use a special type of bar graph called a histogram. Histograms let you compare data in intervals, such as decade to decade, or a range of test scores. The intervals are usually consecutive and usually equal.
This histogram shows a number of students whose test scores fell in these ranges: 60 to 69, 70 to 79, 80 to 89, 90 to 99, and 100. While we can't see what scores each student got, we can see how many students got D's, C's, B's, and A's. At a glance, you can see this is a hard-working class, lots of A's and B's.
Our next type of graph is a scatter plot. Scatter plots show the relationship between two sets of data. Sometimes the relationship is strong, like between swimsuit sales and temperature. Sometimes it's weak, like between test scores and height. Making a scatter plot is a straightforward process.
This table shows the average cost of tuition at a 4-year private college for 2003 to 2007. Don't show your parents. It will give them a heart attack. To make a scatter plot graph, first assign a data set to each axis. Time usually goes on the x-axis, so we'll put the year there and put cost for the y-axis. Add an appropriate scale. Then, map each data point onto the graph.
When there's a strong relationship between the two sets of data, year and tuition costs in this case, the data points will make an identifiable pattern. The pattern might fall along a straight line or a smooth curve, or parabola, or wave pattern, or others too. If the pattern makes a straight line, you may be able to draw a line through the data points to see more clearly the relationship. This line is sometimes called a trend line or line of best fit.
When there's a weak relationship, or none at all, like between test scores and height, the data points will be all over the place. Whether you're tall or short doesn't affect how hard you study and what test scores you get.
So, scatter plots let us know at a quick glance whether two sets of data are related. Next, line graphs.
Line graphs show how results change as an independent parameter changes. Often the independent parameter is time. They are useful for showing both short and long-term trends. Let's go back to our table of the Fighting Gophers.
We're going to convert this table into a line graph. The process is similar to what we did for the bar graph. Put the results, the batting averages, on the vertical axis. Put the time scale on the bottom. Now plot the data for each player. Tim is .405 for April, .365 in May, .344 in June, and .144 in July. Last, connect the dots. And repeat the process for Katie and Hernando.
When you have more than one line, like in this case, you'll want to label each line and make them different colors so people aren't confused. This line graph makes it easy to see how Tim, Katie, and Hernando did throughout the season.